In this problem, we want to evaluate the following sum for n equals 10, for n equals 100, 1000, and 10,000. If we notice and we go ahead and start doing our expansion, we're going to notice that our index is I, so every single term is going to have 1 plus 1 over n squared plus 2 plus 1 over n squared plus so on, so on. Every single, all the way until we get to the n plus 1 over n squared. Every single term is going to have this 1 over n squared, 1 over n squared, 1 over n squared. So it can actually be factored out of our summation. It is a constant, so we are applying one of the properties of summation. So this becomes 1 over n squared times the sum of I equals 1 to n. Well, what is left inside? Nothing but just I plus 1. And remember, this is also another property of summation. When you have two type of things, we can go ahead and separate them. So this is equivalent to 1 over n squared times the summation from I, not from j, from I, just the other way around, from I equals 1 to n of I plus, big parenthesis, the summation from I equals 1 to n of 1. And at this point, you're like, all right, so what are we even doing right now? Well, I'll tell you what we're doing. We're actually trying to rewrite this in such a way that we have a formula for it, that we can establish an equation in terms of n, such that we can just grab that 10, that 100, that 1000, that 10,000, and just evaluate directly. Now the question is, do I know what is the summation of the first I terms? Do we know any of this, something like this? Yes, we have a formula for that. That is equal to 1 over n squared times, well, that is equal to n times n plus 1 over 2 plus, well, the summation of a constant. How many times is this constant going to be added? Well, n times. And remember, this is another property. The summation of a constant of the first n terms is the constant times n. So in this case becomes 1 times n, which is just n. And at this point, we go ahead and put this as two fractions into one fraction. This is over 1. So this is 1 over n squared times n squared plus n over 2 plus, we want the denominator to be 2, so we write 2n over 2. And this becomes equal to 1 over n squared times n squared plus n plus 2n is equal to n squared plus 3n over 2. All right, and this is equal to n squared plus 3n all over 2n squared. And we can simplify 1n that they have in common. So this is equal to n plus 3 over 2n. So what did we just found out? We found out that the sum from I equals 1 all the way to n of I plus 1 over n squared, through all that manipulation, is actually nothing but just equal to n plus 3 over 2n. And using the values that we wanted, we can actually go ahead and calculate the summation for all the first n terms by using this formula. If we go ahead and do that, we have this amazing table. Ta-da! All right, that's what this is saying. It's saying when n is 10, we go ahead and substitute into our function, and we have the value 0.65. As n is 100, we have 0.515, and so on. All right, so notice that as n gets to 10,000, our value becomes 0.50015. So we can actually go ahead and establish this conclusion. As n increases without bound, the value of the sum goes to 0.5. Does that language seems a little bit familiar? It should, because this is nothing but limits. So let's see, what do we get here now? All right, so we already finished the problem. Now let's see why this n, as this n is increasing, why are we approaching 0.5001? Well, let's take the limit as n goes to infinity of what function of n plus 3 over 2n. So remember, our first intuition should be to substitute the value, and in this case we will get infinity over infinity, which is indeterminate form, which means that we have to do some algebraic manipulation, and this becomes the limit as n goes to infinity of n over 2n plus the limit as n goes to infinity of 3 over 2n. Well, this simplifies nicely to the limit as n goes to infinity of 1 over 2 plus the limit as n goes to infinity of 3 over 2n. We can go ahead and substitute our notion of infinity. The limit as n goes to infinity of this constant. If it's a constant and it's being graphed, y equals 1/2, what is the limit of that function? All right, so it looks like this, at y equals 1/2, all right? As the n's go all the way to infinity, kind of like our x's did, right? What is the value of the function? Well, the value is itself 1/2 plus limit as n goes to infinity. Well, what happens if we substitute infinity here? This is going to become infinitely large, all right? 3 divided by an infinitely large number is nothing but approaching a quantity of 0. So the whole value of this limit is nothing but just 1 over 2, which is equal to 0.5. Ta-da! Latino teacher.